Relative Gravity Lecture 4. The Infinity Manifold and the Cookbook for the Universe.
The Cookbook for the Universe aspires to serve as a guide for understanding the creation and evolution of the cosmos. It invites readers, whether they're scientists, theorists, explorers, or thinkers, to consider the underlying principles that drive the universe's emergence and transformation. This work builds on years of exploration and research, beginning with the earlier publication, Essay on Relative Gravity, Using the Mechanics of Object-Oriented Science, originally published in 2014. This foundational text introduced the concept of relative gravity as a revolutionary framework for understanding the universe. The book challenged traditional models by proposing a dynamic, interconnected system where symmetry is conserved through polymorphism of inherent properties. It explored the fundamental relationship between light and dark matter, the alternating currents of existence, and how forces unify across dimensions. These ideas laid the groundwork for the Cookbook for the Universe. The journey from relative gravity to the Cookbook was one of expansion, refining theories, integrating new insights, and building a cohesive framework for the cosmos. Where Essay on Relative Gravity addressed the universe's structure and forces, the Cookbook delves deeper into the interplay of time, dimensions, and the mechanisms that drive creation and evolution. Together, they form a continuum of thought, seeking to redefine how we view existence itself. By presenting a conceptual framework, it seeks to provide tools for navigating the interplay between forces, potentials, and dimensions, opening the door to new perspectives on the cosmos. To interpret the key ideas of the Cookbook for the Universe, this commentary introduces the concept of the infinity manifold as a lens through which we can understand the book's discussions on evolution and transformation. While the singularity often represents a point of origin in cosmology, a dense, initial state of the universe, the infinity manifold provides a way to conceptualize the space of all latent possibilities. It reflects the interconnected system of forces and dimensions described in the book and offers a means to examine how these potentials evolve into the observable universe. By Orion Carl Daly II. The Infinity Manifold and the Cookbook for the Universe. Imagine a room full of manifolds where the lights are out. Each manifold represents a unique potential, unseen and unexpressed. When light enters the room, these manifolds are revealed, interacting dynamically with one another and transforming into a visible, observable system. This metaphor encapsulates the interplay between the x-plane external infinity, the observable, the y-plane internal infinity, the latent, and the z-axis, the vector of transformation or time that the infinity manifold seeks to frame. The book's concepts, such as the delta phenomenon and the dimension of time, are integral to this framework. They guide readers through the mechanisms by which the universe transitions from potential to expression, illuminating how interconnected forces shape its evolution. By offering the infinity manifold as a conceptual tool, this commentary aims to deepen engagement with the ideas of the Cookbook for the Universe while fostering a collaborative dialogue about the nature of existence. 1.1 The Infinity Manifold and Perspective. This diagram serves as both a conceptual map and a visualization tool, connecting the foundational ideas of the Cookbook for the Universe to the principles of the infinity manifold. At its center is the Mobius waveform, representing the infinite cycles of transformation and connectivity that define the evolution of the universe. Its continuous, looping structure reflects the seamless interplay between the dimensions of the manifold, the x-plane external infinity, the y-plane internal infinity, and the z-axis time. On the far right, the lens of perspective acts as the key to interpreting the system. The lens symbolizes the infinity manifold itself, offering a way to see the intricate structure of infinity and its dynamic interactions. Looking through the lens, one is invited to explore not just the Mobius waveform but the very heart of the universe's processes, the singularity. The singularity, often perceived as an abstract or incomprehensible point, is revealed here as the origin and the center of infinite potential. Through the lens, the singularity becomes a focal point where internal and external infinities converge and where time drives the transformation of potential into expression. It is the node that anchors the manifold, enabling the cyclical emergence of phenomena within the universe. By Orion Carl Daly III. Aka. Essay on Relative Gravity. To describe the mechanics of the universe, this perspective reinforces the idea that infinity is not just an abstract expanse but a structured, dynamic process. The Mobius waveform illustrates how this process is continuous and interconnected, while the lens provides the means to observe and interpret it. Together, they offer a pathway to understanding how the infinite interacts with the finite, how potential unfolds into reality, and how the universe evolves through cycles of creation and transformation. Ultimately, this diagram challenges the observer to rethink the nature of the singularity. It suggests that with the right tools like the infinity manifold and the lens of perspective, we can not only conceptualize infinity, but also begin to look directly into the singularity itself, uncovering its role as the driving force behind the universe's evolution. By Orion Carl Daly IV. The Infinity Manifold and the Cookbook for the Universe Section 2, the Delta Phenomenon and the Evolution of Potential. Central to the ideas explored in the Cookbook for the Universe is the Delta Phenomenon, a principle that seeks to explain the iterative evolution of the universe. In this context, the Delta Phenomenon represents the mechanism by which latent potential transitions into observable phenomena. It is the process through which the infinite possibilities contained within the y-plane, the internal infinity, are expressed within the x-plane, or the external, observable universe. The Delta Phenomenon, as articulated in the book, suggests that evolution occurs not as a singular event, but as a continuous, cyclical process. Each cycle builds upon the previous one, with each iteration contributing to the universe's complexity and interconnectedness. This phenomenon mirrors the concept of growth in nature, where iterative processes, such as the unfolding of a flower or the growth rings of a tree, reflect an underlying order and structure. Through the lens of the infinity manifold, the Delta Phenomenon can be seen as the dynamic interaction between the three planes, the latent potential of the y-plane, the manifest reality of the x-plane, and the transformative force of the z-axis, or time. Each iteration of the Delta Phenomenon draws from the infinite well of potential and refines it through time, resulting in the diversity and structure we observe in the universe today. This process also underscores the fractal-like nature of existence. Just as fractals exhibit self-similarity across scales, the Delta Phenomenon reveals patterns that repeat and evolve from the quantum to the cosmic level. By framing the Delta Phenomenon within the infinity manifold, we can begin to understand the intricate interplay between potential and reality, and how the universe achieves balance and coherence through iterative cycles. The Cookbook for the Universe uses the Delta Phenomenon to guide readers through these concepts, not as definitive answers but as tools for exploration. It invites physicists, scientists, and thinkers to consider how these cycles of evolution might not only shape the physical universe, but also provide insights into time, energy, and the very fabric of existence. By Ryan Carl Daly 5. Aka. Essay on Relative Gravity to Describe the Mechanics of the Universe Section 3. The Dimension of Time, the Vector of Transformation. Time is often thought of as a linear progression, a series of moments passing from past to future. However, as explored in the Cookbook for the Universe, time is far more dynamic and multifaceted. Within the framework of the infinity manifold, time is not merely a measure of change. It is the very force that enables transformation, bridging the latent potential of the y-plane with the expressed realities of the x-plane. The z-axis, representing the dimension of time, becomes the vector through which evolution unfolds. The accompanying diagram illustrates this concept by portraying time as a flowing, multidimensional spectrum. Rather than existing as a static or linear axis, time is shown as a dynamic interplay of layers, each representing iterations or phases of transformation. Points like D0, D1, D2 along the curve signify iterative cycles, where potential within the y-plane transitions into observable expression in the x-plane. This recursive process reflects the Delta Phenomenon, where time enables the infinite to manifest through continuous cycles of growth and refinement. Time in this framework does not act in isolation, but as a key dimension within the manifold. Each curve in the diagram interacts dynamically with the other dimensions, suggesting that time is as integral to the manifold as the x and y planes. By Ryan Carl Daly 6. The infinity manifold and the Cookbook for the Universe, it serves as the medium through which internal infinity potential is connected to external infinity expression, ensuring that the manifold remains a coherent and evolving system. The spiraling nature of the diagram also underscores the fractal-like qualities of time. Just as fractals exhibit self-similarity across scales, the dimension of time reveals patterns that repeat and evolve from the quantum to the cosmic level. These patterns are not merely reflections of time as passage, but active demonstrations of its role as the z-axis, a transformative force that drives the interactions and relationships within the manifold. Ultimately, the dimension of time provides a lens through which we can observe the singularity itself. The singularity, often thought of as a static point of origin, is revealed here as the center of infinite potential. Through the iterative action of time, the singularity becomes a dynamic node where latent possibilities are continuously transformed into reality. Time, therefore, is not just a passive backdrop for the universe's events, but an active participant in the ongoing cycles of creation and evolution. This interplay between dimension and time challenges conventional notions of temporality and spatiality. By redefining time as an integral dimension of the infinity manifold, the Cookbook for the Universe invites readers to see it not as a linear trajectory, but as the vector of transformation that underpins the universe's unfolding story. By Ryan Carl Daly 7. Aka. Essay on Relative Gravity to Describe the Mechanics of the Universe Section 4. The Emergence of Complexity. As the universe evolves, complexity arises not as a random byproduct, but as a result of the dynamic interplay between dimensions, potentials, and time. Within the framework of the infinity manifold, complexity is the natural outcome of iterative cycles governed by the Delta Phenomenon. Each cycle transforms latent potential into structured expression, continuously building upon previous iterations to create an increasingly intricate cosmos. The x-plane external infinity and y-plane internal infinity form the foundational dimensions where this emergence occurs. The y-plane serves as a reservoir of potential, an infinite well of possibilities that exists within the singularity. The x-plane, in turn, is the domain of manifestation, where these potentials are expressed as observable phenomena. The z-axis, representing time, drives the transformation, enabling potential to flow into expression through iterative cycles. In these cycles, complexity emerges not as an isolated phenomenon, but as a fractal-like process. Just as fractals exhibit self-similarity and growth across scales, the delta phenomenon reveals how patterns of transformation repeat and evolve. From the subatomic to the galactic, the interplay of dimensions ensures that each iteration refines and integrates prior states, producing systems of increasing sophistication and coherence. This emergence of complexity is perhaps most evident in the interplay of forces and phenomena that shape the universe. From the formation of stars and galaxies to the evolution of life itself, the infinity manifold provides a framework for understanding how simple interactions give rise to intricate systems. The manifold reveals that complexity is not an anomaly but an intrinsic feature of the universe's design, driven by the continuous interaction of its dimensions. Through the lens of the infinity manifold, complexity is seen as both a product and a driver of the universe's evolution. Each iteration of the delta phenomenon builds upon the structures created before it, ensuring that the universe remains dynamic, interconnected, and ever-evolving. This perspective invites readers to view complexity not as a challenge to be unraveled, but as a testament to the profound order underlying existence. By Ryan Carl Daly 8. The Infinity Manifold and the Cookbook for the Universe Section 5, Unifying Forces through the Infinity Manifold. At the heart of the Cookbook for the Universe lies a powerful concept, the uniform relative force URF. This principle provides the mathematical and conceptual framework for understanding how forces gravity, electromagnetism, and the nuclear forces emerge and interact across scales. Within the lens of the infinity manifold, URF becomes the key to unifying these forces, revealing the interconnected nature of the universe. The URF formula, expressed as URF equals 4 pi r square root RET, establishes the surface tension or cohesive boundary for a manifold. Here, R represents the spatial radius, E captures the amplitude or energy associated with the radius, and T defines the temporal or time-related aspect of the radius. Together, these components describe the dynamic interactions that occur within and across manifolds. Through the infinity manifold, URF takes on a profound significance. It explains how forces arise from the interplay of internal infinity y-plane and external infinity x-plane, mediated by time z-axis. The formula reveals that every manifold has a surface defined by its radius and energy over time, creating a dynamic system where forces are not isolated but intrinsically tied to the properties of space and time. In this framework, gravity becomes more than a distortion of spacetime. It emerges as a relational property within the manifold, governed by the URF. Similarly, the other fundamental forces, electromagnetism, strong and weak, are unified through their shared origins in the same relative properties. The infinity manifold magnifies these relationships, providing a lens to observe how forces interact, converge, and evolve within the universe. By incorporating the principles of URF, the infinity manifold becomes not just a conceptual tool, but a unifying structure. It bridges the abstract and the physical, showing how forces manifest as the iterative cycles of the delta phenomenon refine and integrate potential into observable phenomena. This unification invites us to rethink the nature of the forces that govern the cosmos, seeing them not as distinct entities but as facets of a single, interconnected reality. Through this lens, the singularity at the heart of the manifold is no longer an enigmatic point. It is the origin of all relative forces, the source of the manifold's coherence, and the anchor for the universe's evolution. URF provides a way to quantify and understand this unity, offering a mathematical foundation for the interconnected dance of forces that shape the cosmos. By Ryan Carl Daly 9. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe Section 6, Observing the Singularity, the Inertial Frame, and the Shrinking Universe. At the core of the Cookbook for the Universe lies the singularity, a concept reimagined as a dynamic and transformative center of infinite potential. Far from being a static point of origin, the singularity acts as an inertial frame of reference, anchoring the universe as cycles of evolution and transformation. Through the lens of the infinity manifold, the singularity becomes a focal point for understanding how the universe unfolds. One of the most intriguing ideas explored within this framework is the concept of a shrinking universe. From the perspective of the singularity, all dimensions, spatial x-plane, latent y-plane, and temporal z-axis interact dynamically, creating the perception of relative shrinking. By Ryan Carl Daly 10. The infinity manifold in the cookbook for the universe. This shrinking is not absolute but emerges as a consequence of the observer's frame of reference. The singularity, as the unchanging node within the infinity manifold, provides the stable point against which all transformations are measured. This perception of a shrinking universe exists in juxtaposition to the widely accepted theory of an expanding universe. Within the framework of the infinity manifold, these seemingly opposing views are revealed to be two sides of the same coin. Whether the universe appears to shrink or expand depends entirely on the observer's frame of reference and the lens through which these transformations are interpreted. In effect, one perception is the inverse of the other, both describing the same dynamic processes within the manifold. The shrinking can be understood as a natural result of the manifold's iterative cycles. As the universe evolves, potential from the y-plane is expressed within the x-plane, guided by the z-axis time. From the singularity's perspective, this iterative process creates the illusion of contraction, as each cycle refines and integrates prior states into increasingly sophisticated forms. Conversely, from a vantage point within the x-plane, these same dynamics can give the impression of expansion, as observable phenomena spread out over space and time. This concept highlights the importance of perspective in interpreting cosmic phenomena. Just as the lens of perspective in the infinity manifold allows us to observe and understand the dynamics of infinity, it also shapes our perception of the universe's behavior. Whether we see the universe as expanding, shrinking, or cycling depends on our vantage point and the frame of reference we adopt. By reframing these ideas, the cookbook for the universe challenges conventional notions of cosmology. It reveals that the distinction between a shrinking and an expanding universe is a matter of interpretation rather than contradiction. Through the infinity manifold, we gain a deeper understanding of how dimensions, forces, and time interact dynamically within the singularity's framework, paving the way for exploring the multiverse in greater depth. By Orion Carl Daly 11. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe Section 7. The Multiverse and the Infinity Manifold. Imagine a room filled with crystal balls, each suspended in darkness. Every ball represents a unique universe, a manifold containing its own dimensions, forces, and temporal flow. When a single beam of light enters the room and touches one ball, the light scatters, refracting and illuminating the others. The interconnected reflections reveal the hidden structure of the room, demonstrating how each universe influences and interacts with the others. This analogy encapsulates the multiverse as described in the cookbook for the universe. The infinity manifold, introduced earlier, is the framework that unifies and explains the intricate relationships between these universes. It reveals that the multiverse is not a random collection of independent systems, but a dynamic network of interconnected manifolds, unified by shared principles like the delta phenomenon, uniform relative force URF, and the dimension of time. 7.1 Introducing Key Concepts. Before diving deeper, it is crucial to revisit and define the terms central to this discussion. Infinity manifold, a conceptual lens for understanding how infinite potential transforms into observable phenomena. It integrates dimensions x, y, z, time, and forces into a cohesive framework. Delta phenomenon, the iterative process by which potential is expressed as observable reality. It governs the cycles of transformation across the manifold, creating and refining singularities. Uniform relative force URF, a principle that defines the surface tension or boundary of a manifold. Dimension of time z-axis, the transformative vector that bridges the latent potential y-plane with expressed reality x-plane. Time in this context is dynamic and cyclical, not linear, and allows for infinite derivatives. 7.2 The singularity as the nexus. At the center of the multiverse lies the singularity, a dynamic nexus of infinite potential. Unlike traditional views of the singularity as a static point, the cookbook for the universe positions it as the origin and anchor for all manifolds. The singularity cycles between dormancy and activation, releasing energy in dimensions that form individual universes. By Orion Carl Daly 12. The infinity manifold and the cookbook for the universe through the delta phenomenon, the singularity operates as a mechanism for transformation, creating unique universes through iterative cycles. Each singularity is shaped by the infinite derivatives of the dimension of time, which provide the temporal frameworks necessary for new manifolds to emerge. This process demonstrates that the singularity is not just a point of creation, but a continuous source of evolution within the multiverse. 7.3 Harmonic resonance and stability. Universes within the multiverse maintain coherence through harmonic resonance. Much like how radio stations broadcast on different frequencies without interfering, each manifold operates at its own unique resonance. This ensures that the multiverse remains stable and prevents destructive interference between universes. The radio station analogy complements the crystal ball analogy. illustrating how the infinity manifold acts as the spectrum that organizes and harmonizes these frequencies. Each manifold broadcasts its own signal, contributing to the overall harmony of the multiverse while retaining its individuality. 7.4 The delta phenomenon and singularities. The delta phenomenon plays a pivotal role in this process by driving the transformation of potential into observable phenomena. Within the infinity manifold, it governs the evolution of singularities, ensuring that they act as dynamic centers for their respective manifolds. Through cycles of refinement and iteration, the delta phenomenon bridges the infinite potential of the y-plane with the express realities of the x-plane, guided by the z-axis. These cycles are not isolated, they influence and interact with one another through the singularity. The singularity, as the hub of the multiverse, ensures that these interactions remain coherent and balanced, mediated by the harmonic resonance within the manifold. 7.5 Dimension of time and its infinite derivatives. Central to the multiverse is the dimension of time, recognized not as a finite or linear construct, but as an infinite continuum. Time, as represented by the z-axis, is more than a medium for transformation, it is an endless source of potential, capable of producing infinite derivatives. Each derivative represents a distinct temporal framework, enabling the emergence of unique singularities and universes. By Ryan Carl Daly 13. Aka, Essay on Relative Gravity to describe the mechanics of the universe. These derivatives of time serve as the foundation for multiple universes within the multiverse. Each universe exists as a distinct expression of time's potential, shaped by its own temporal dynamics, spatial dimensions, and resonance properties. The infinity manifold provides the structure through which these derivatives and their resulting universes are observed and unified. 7.6 Back-end, Mathematical and Theoretical Rigor. 7.6.1 Manifolds as universes. Each universe is defined by its URF, which quantifies the interaction of dimensions, radius, energy, and time. The formula ensures the structural integrity and boundaries of each manifold. Example: a universe with a smaller RRR radius and higher E energy might exhibit different temporal dynamics than one with a larger radius and lower energy. 7.6.2 Harmonic resonance. Resonance is defined mathematically by the relationship between frequencies of interacting manifolds. Stability arises when these frequencies align harmonically. Include specific resonance equations to demonstrate how interference is mitigated. 7.6.3 Time across universes. Time, as the z-axis, operates differently in each manifold, but remains unified through iterative cycles of transformation. Temporal dynamics are modeled using variations in t across universes. Example: a manifold with accelerated t might appear to evolve faster relative to another, but both remain connected through the singularity. 7.6.4 Connecting the analogies. The crystal ball analogy aligns with how energy and light activation flow between manifolds, revealing their interconnectedness. The radio station analogy illustrates how each manifold's resonance contributes to the broader harmony of the multiverse. By Ryan Carl Daly 14. The Infinity Manifold in the Cookbook for the Universe Section 8. Expanding Perspectives, the basis for a multiverse. Building on the conceptual frameworks of dimensions, relative forces, and manifolds, this section introduces the profound notion of a multiverse, a cosmos of infinite possibilities and interactions. Using the metaphor of a room of dormant crystal-like structures, we explore how energy and light, represented by the delta phenomenon, can activate universes and harmonize their dynamic properties. The basis for a multiverse outlines how overlapping spaces, harmonic resonances, and unique spatial times contribute to the structure and coexistence of universes. Through this lens, the multiverse emerges not as a theoretical abstraction, but as a tangible framework grounded in the principles of relative gravity. The concepts introduced here expand the boundaries of scientific inquiry, proposing new pathways for understanding existence at both macro and microcosmic scales. By Ryan Carl Daly 15. Aka, Essay on Relative Gravity to describe the mechanics of the universe. The section seeks to synthesize rigorous scientific analysis with the poetic beauty of interconnected systems, bridging the abstract with the observable, and the theoretical with the empirical. The universe, as we observe it, is a marvel of interconnected forces, dynamic interactions, and infinite potential. But what if our universe were not alone? What if it were just one of many, coexisting in a shared space, each with its own rhythm, its own time? These questions have sparked countless theories, yet the answers remain elusive. Imagine stepping into a vast, infinite room shrouded in darkness. In this room, crystal-like structures, manifolds, fill the space from floor to ceiling. They sit silent, dormant, waiting. Then a single light flickers in the distance. Its faint ray touches one manifold, and suddenly, the room begins to transform. The light refracts, scattering into countless beams, igniting manifold after manifold in a cascading symphony of illumination. Patterns emerge on the walls and ceiling, swirling galaxies, intricate fractals, and the echoes of infinite potential. This room is a metaphor for the multiverse, a place where universes coexist, interact, and evolve through the principles of relative gravity. This paper explores a groundbreaking framework for understanding the multiverse through the principles of relative gravity. By examining how overlapping spaces and distinct spatial times govern interactions at every scale, we uncover the profound mechanisms that make the coexistence of universes not only possible but inevitable. Using the metaphor of a room filled with dormant crystal-like structures, we demonstrate how light or energy can awaken these universes, revealing their unique properties and interconnected harmonies. Through this journey, we will bridge poetic imagery with rigorous science, blending the abstract beauty of a multiverse with the concrete principles of physics. Our goal is to not only theorize but to inspire, to provide a framework for exploring existence itself. 8.1. Foundation: Establishing core concepts. Dimension of time in the framework of relative gravity is understood as an infinite, dynamic continuum, not bound by linear constraints. Manifolds in the context of relative gravity are multidimensional structures that embody the dynamic properties of energy, time, and force. Relative gravity introduces the principle of overlapping spaces and distinct spatial times, which allows for the coexistence of multiple universes within a shared space. By Orion Carl Daly, 16. The Infinity Manifold and the Cookbook for the Universe. 8.2. Expanding the room of manifolds metaphor. As the light interacts with the crystal-like manifolds in a room, a cascade of transformations unfolds. Each manifold refracts the light in unique ways, creating intricate patterns and harmonies that ripple across the space. This section explores the dynamics of these interactions and their implications for understanding the multiverse. Light as an initiator. The light represents the delta phenomenon, the initiating force that activates dormant manifolds. As it travels through the room, the light's interaction with each manifold symbolizes the interplay of energy and time, setting the manifold into motion and revealing its unique properties. This activation demonstrates how universes emerge from potential states into observable phenomena. Cascading interactions. When the light touches a manifold, its refraction creates new beams that propagate outward, illuminating other manifolds. This cascading effect mirrors how universes influence one another through shared forces and dimensions. The resulting interplay of light and manifolds represents the interconnectedness of the multiverse, where each universe contributes to the larger system as harmony. Patterns of coexistence. The patterns created by the refracted light, swirling galaxies, fractal designs, and geometric shapes symbolize the observable phenomena that arise from manifold interactions. These patterns demonstrate how universes can coexist in the same space while maintaining distinct identities through unique spatial times and harmonic resonances. By Orion Carl Daly, 17. Aka, Essay on Relative Gravity to describe the mechanics of the universe, harmonic resonance and stability. The stability of the multiverse relies on harmonic resonance. Each manifold resonates at a specific frequency, ensuring that its interactions with other manifolds remain coherent and non-destructive. This principle prevents interference and allows for the dynamic coexistence of overlapping spaces and spatial times. A model for the multiverse. The room of manifolds provides a conceptual model for the multiverse, where universes coexist, interact, and evolve through principles of relative gravity. By understanding the dynamics of light, manifolds, and harmonic resonance, we can uncover the mechanisms that govern the multiverse's structure and behavior. 8.3. Bridging poetic metaphor and rigorous science. The poetic metaphor of the room of manifolds provides an engaging entry point, but its power lies in how it can bridge abstract beauty with rigorous science. This section explores the scientific principles and mathematical frameworks that connect the metaphor to observable and theoretical phenomena. By Orion Carl Daly, 18. The Infinity Manifold and the Cookbook for the Universe. 8.3.1. Wave dynamics and refraction. In scientific terms, the interaction of light with manifolds can be described using wave dynamics. Each manifold acts as a refractive medium, altering the path and properties of the light that passes through it. This process can be modeled using equations that describe wave propagation, refraction, and interference. The unique patterns created by each manifold reflect its intrinsic properties, much like how universes in the multiverse exhibit distinct characteristics while sharing a common framework. 8.3.2. Harmonic oscillators and resonance. Manifolds can also be modeled as harmonic oscillators, each vibrating at a specific frequency. These frequencies represent the spatial times of the manifolds, ensuring that their interactions remain stable and coherent. Harmonic resonance prevents destructive interference, allowing manifolds to coexist and influence one another constructively. This principle is central to the stability of the multiverse. 8.3.3. Dimension of time as a universal scaffold. The dimension of time, as conceived in relative gravity, serves as the scaffolding that supports the cascading interactions of manifolds. Time is not linear but an infinite, dynamic continuum that stretches and compresses, enabling the iterative evolution of systems. In a room of manifolds, The light's journey through the space symbolizes how energy propagates through this temporal scaffold, activating dormant universes and initiating cycles of interaction. 8.3.4 Temporal resonance and stability. Just as manifolds resonate harmonically to maintain spatial coherence, they also resonate temporally. Each manifold exists within its unique spatial time, a distinct rhythm that ensures its stability within the shared continuum of the multiverse. Temporal resonance prevents conflicts between universes, much like harmonic resonance prevents interference between overlapping frequencies. 8.3.5 Observable manifestations of temporal dynamics. The interplay of light, manifolds, and time gives rise to phenomena that can be observed and studied. For example, by Ryan Carl Daly 19. Aka, Essay on Relative Gravity to describe the mechanics of the universe. Gravitational wave timing. Variations in the timing of detected gravitational waves could reveal the influence of temporal resonance across manifolds. Cosmic background radiation signatures. Fluctuations in the cosmic background radiation may reflect temporal distortions caused by manifold interactions. Time-space coupling in quantum systems. At smaller scales, the coupling of time and space within quantum systems might mirror the cascading dynamics seen in the room of manifolds. 8.3.6 Expanding scientific horizons. By connecting the metaphor to rigorous science, we not only enrich our understanding of the multiverse but also open new avenues for research. The room of manifolds becomes more than an abstract idea. It serves as a framework for exploring the fundamental principles that govern existence. 8.4 Applications and implications of the framework. 8.4.1 Advancing multiverse theory. The framework of relative gravity and the room of manifolds metaphor provides a new lens for refining multiverse theories. By emphasizing overlapping spaces and harmonic resonance, it bridges gaps in existing models like string theory and quantum mechanics, offering a unified perspective. This approach not only explains how universes coexist, but also how they influence one another dynamically, challenging traditional notions of isolated realms. 8.4.2 Investigating observable phenomena. Future advancements in observational technology could bring this framework closer to empirical validation. Instruments like gravitational wave detectors might identify unique wave patterns indicative of manifold interactions. Similarly, anomalies in cosmic background radiation could reflect temporal or spatial distortions arising from the cascading effects of manifold interactions. These phenomena provide exciting opportunities for testing the theoretical predictions of relative gravity. 8.4.3 Cross-disciplinary connections. This framework connects physics, philosophy, and mathematics to create a holistic understanding of existence. By integrating concepts like the delta phenomenon and temporal resonance, it offers insights that extend beyond traditional scientific boundaries. These interdisciplinary connections could redefine how we approach complex systems, from the behavior of subatomic particles to the evolution of galaxies. By Ryan Carl Daly 20. The Infinity Manifold and the Cookbook for the Universe. 8.4.4 Philosophical implications. The concept of interconnected universes challenges conventional ideas of separation and isolation, promoting a vision of unity and harmony. It suggests that existence itself is a tapestry of interactions, where every thread contributes to the greater whole. This perspective invites deeper reflection on the nature of reality and our place within the cosmos. 8.4.5 A framework for new science. By providing a robust foundation for exploring the multiverse, relative gravity and the room of manifolds metaphor pave the way for groundbreaking discoveries. From understanding the nature of dark matter to advancing quantum computing, this framework has the potential to inspire the next generation of scientific innovation. It encourages researchers to think beyond established paradigms and embrace the interconnected nature of existence. By Ryan Carl Daly 21. Aka, Essay on Relative Gravity to describe the mechanics of the universe. 8.5 Radio stations and harmonic means, a unified analogy. 8.5.1 The radio station analogy. The multiverse can be envisioned as analogous to a vast spectrum of radio frequencies. Each universe operates at its own unique frequency spatial time, ensuring that it does not interfere with others. Much like radio stations broadcasting distinct signals, the coherence of these frequencies mirrors the harmonic resonance of manifolds, where interactions are constructive and stability is preserved. Overlapping signals. Despite sharing the same physical space, radio frequencies remain distinct due to their unique wavelengths and amplitudes. Similarly, universes coexist within the multiverse by operating on separate spatial times, avoiding destructive interference. Tuning into universes, just as a radio receiver can be tuned to a specific station. Tuning into universes, just as a radio receiver can be tuned to a specific station. The theoretical framework of relative gravity suggests that observing a universe involves aligning with its unique spatial time and frequency. by Orion Carl Daly 22. The Infinity Manifold and the Cookbook for the Universe 8.5.2. Harmonic means as a mathematical tool. Harmonic means offer a mathematical representation of the relationships between frequencies and resonances within the multiverse framework. Resonance relationships. The harmonic mean captures the average dynamics of interacting manifolds, providing insight into how their resonances align and stabilize. Temporal synchronization. Applying harmonic means to spatial times allows us to quantify the synchronization of temporal dynamics between universes. 8.5.3. Unified stability through resonance. Combining the radio analogy with harmonic means illustrates the elegant stability of the multiverse. Each universe's unique frequency contributes to a larger harmonic structure, much like a symphony where every instrument plays its part. The result is a stable and coherent multiverse, governed by the principles of relative gravity and harmonic resonance. By Orion Carl Daly 23. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 8.6. Experimental Pathways in Future Explorations. 8.6.1. Validating Manifold Interactions. Gravitational Wave Analysis. Explore how gravitational waves might exhibit unique interference patterns or frequencies caused by manifold interactions. Points of harmonic resonance between manifolds could create detectable echoes or anomalies in wave data, observable with instruments like LIGO or the Einstein telescope. For example, phase shifts in gravitational waves could indicate energy propagation across overlapping spatial times. Cosmic background radiation anomalies. Examine the cosmic microwave background CMB for distortions or hotspots that reflect interactions between adjacent manifolds. Such anomalies could correspond to the cascading effects of light described in the room of manifolds metaphor. Advanced telescopes, like the James Webb Space Telescope, could pinpoint these subtle deviations. High-energy particle experiments. Use particle accelerators like CERN's Large Hadron Collider to replicate extreme conditions where manifold interactions might manifest. Collisions at unprecedented energy levels could reveal phenomena such as temporal distortions or unique particle formations. For instance, observing deviations in expected particle decay rates might suggest the influence of manifold dynamics. 8.6.2. Technological innovations. Advanced detectors. Develop hypersensitive instruments capable of detecting minute gravitational fluctuations or temporal shifts. These detectors could listen for the unique resonance signatures of manifold interactions. An example might be a space-based array designed to track microsecond-level changes in gravitational fields. Quantum computing applications. Utilize principles of temporal synchronization to advance quantum computing. Understanding how manifolds resonate at distinct frequencies could inspire algorithms optimized for complex quantum states. For example, a quantum computer could simulate manifold interactions, aiding both physics research and computational sciences. 8.6.3. Simulations and computational models. Multiverse simulations. Design computational models to simulate the cascading effects of manifold interactions. These simulations would visualize how spatial times overlap and harmonize. Imagine a 3D simulation animating the propagation of energy through dynamic multiverse layers. By Orion Carl Daly 24. The Infinity Manifold and the Cookbook for the Universe I in Physics leverage artificial intelligence to analyze data from gravitational wave detectors or CMB studies. Machine learning could identify subtle patterns that align with the theoretical predictions of relative gravity. For instance, an AI model trained to detect harmonic resonance could refine experimental targets. 8.6.4. Philosophical and theoretical implications. Revisiting fundamental questions, challenge existing notions of isolation in the universe. Instead, propose a model where interconnectedness is the default, redefining time, space, and energy as emergent from harmonic manifold interactions. This new perspective could transform how humanity views its place in the cosmos. Ethical considerations. Reflect on the philosophical impact of proving the multiverse's existence. What responsibilities arise from such a discovery? How might it reshape cultural and spiritual frameworks? These questions warrant deep exploration as science advances. 8.6.5. Bridging theory and practice. Interdisciplinary collaboration. Encourage partnerships among physicists, engineers, philosophers, and computer scientists to create a cohesive approach. For example, gravitational wave researchers could collaborate with quantum computing experts to test relative gravity's predictions. Roadmap for experimental testing. Propose a systematic plan from hypothesis to testing, beginning with simulations and culminating in empirical observations. This roadmap might include designing observatories specifically to detect subtle signatures of manifold interactions. By Orion Carl Daly 25. Aka, Essay on Relative Gravity to Describe the Mechanics of the Universe 8.7. The Broader Implications of Relative Gravity in Multiverse Exploration. 8.7.1. Redefining the Nature of Reality. Relative gravity reshapes how we perceive reality by emphasizing interconnectedness at every level. In this framework, space, time, and energy are not isolated but are woven together in a dynamic tapestry. Each manifold contributes to the multiverse's collective harmony, redefining existence as a system of relationships rather than isolated entities. This new understanding challenges traditional physics, offering a unified framework that explains how forces and dimensions emerge and interact. The multiverse no longer represents an abstract theory, but a tangible possibility grounded in principles like harmonic resonance and temporal dynamics. 8.7.2 Humanity's place in the cosmos. Proving the existence of a multiverse would transform humanity's understanding of its role in the cosmos. Instead of existing as a singular phenomenon, our universe becomes part of an infinite, interconnected web. This perspective invites profound existential reflection. Culturally, this discovery could inspire new myths and metaphors about our place within the vastness of creation. Philosophically, it redefines individuality and universality, showing how every part contributes to the whole. Humanity, as both observer and participant, becomes a vital thread in this cosmic fabric. 8.7.3 Advancing interdisciplinary science. Relative gravity highlights the necessity of integrating diverse disciplines to fully understand the multiverse. Physics, mathematics, philosophy, and even the arts converge to interpret these profound truths. Future research inspired by this framework might explore dark energy's role as an underlying manifold force or develop computational models that simulate multiversal dynamics. By fostering collaboration across fields, this work lays the foundation for a new era of discovery. By Orion Carl Daly 26. The Infinity Manifold and the Cookbook for the Universe 8.7.4 Ethical and Practical Considerations. The exploration of the multiverse brings ethical questions to the forefront. What responsibilities accompany such profound knowledge? How do we ensure this exploration benefits all of humanity without compromising safety or integrity? Practically, understanding manifold dynamics could inspire groundbreaking technologies. Energy systems based on temporal resonance, advanced communication tools, and even new frameworks for artificial intelligence could emerge from this research. These innovations would not only advance science but also improve daily life. 8.7.5 Inspiring a Visionary Future. Ultimately, this work is a call to action not just for scientists, but for humanity as a whole. It challenges us to think beyond the known, to embrace curiosity, and to reimagine our place in the cosmos. By making these ideas accessible, we can inspire future generations to explore not just the universe but existence itself. The multiverse framework is not just a scientific model, it is a vision for understanding and harmonizing the infinite potential within and beyond us. As we uncover its mysteries, we are reminded of the boundless possibilities inherent in the act of exploration.